All right. Welcome, Rahul. So today we are starting our Tech Spotlight series of 100 episode. And today our special guest is Mr. Rahul Singh. Hi, Rahul.
So first of all, thank you, Abinash, for having me here. It's very exciting to be a part of this podcast and a technical discussion. We have been having offline tech discussions off and on many times, uh, but this is probably the first time when we are having it on online in this manner.
Yes.
So
And
yeah,
that's why I'm very excited because this is our first episode also, and you are my special guest today. So,
thank you.
yes. And
It's an honor.
yes.
Health, like your database, searches are slower than a snail on vacation. Meet Fize, the rock star of vector databases, here to save your data queries and your patience. Hi, I am Abinash Mishra, and let's discuss the Fize vector database in brief. Fize stands for Facebook, AI Similarity Search. Basically, it's a supercharged tool that can find similar items in large datasets faster than you can finish saying artificial intelligence. Imagine having to find a needle in a haystack. The face is like, hold my beer, and does it in milliseconds. Fize isn't just fast, it's freakishly efficient. Need to search through billions of vectors? Fize says, no problem. I've got GPUs for that. Need a scalable solution? Fize goes, yeah, I'm multilingual. CPU, GPU, you name it. It's like the Usain Bolt of databases. If Usain Bolt also happened to have a PhD in machine learning, Fize powers recommendation systems, AI search engines, and even those creepily accurate product suggestions you get online. It's the secret sauce for anyone working with embeddings or similarity search. Want your projects to scale faster than cat videos on the internet? PyESS is your new best friend.
And we both will try to give as much as possible in a very fundamental way about the vector database in this episode. So for audience who are watching us in this episode, they are definitely going to get three key parameters here from this episode. One is uh, to understand how this vector database is going to use in real world application. That is the first thing. Second, they will definitely get to understand what are the key understanding of vector database, what are the key core technology underlying work in vector database component. And the third, they will also understand, and that insight they will get from you, especially as an industry expert, that what would be the future roadmap for that vector database. So these three key parameters they will get in this episode. So to start with this discussion, let me ask you very simple and very fundamental question. What is vector database and why is it considered to be GPS for data?
I think it is uh, it's it's quite a fundamental and really a great question. So to understand what is a vector database, we have to understand that the quality of data as such has actually changed.
Yes.
So when we are typically visualizing a typical data, it would be very much in form of an Excel sheet or a table.
Right.
So it is always a kind of a matrix. And when we are defining a matrix, the primary uh, design of data is in form of structure. So if my data, my every row is actually one data set which is having n number of parameters. Now imagine a situation when this is not the case. When my when the veracity of my data is so much that I cannot really arrive at a particular structure in it, how do I store it?
Right, right.
And as things are, as the data is increasing, so the quantity of data is not the problem. The variety in the data is the problem.
Oh,
When it
yes.
comes to variety in the database, we need to have something which is more fundamental than the obvious structure in it.
Mm.
In data, there is always a latent structure. So latent structure cannot be captured by a relational database. You need to have something like a vector database where the parameters are vectorized for each element. So, for example, like the example you have given that like the street map or basic street sign versus the GPS.
Yes, yes.
So, when we are defining something like a street map, what we do? We say that this is X city. In the X city, this is the Y main street. There is a particular road or a particular street, and on the street it would be block number 5, uh, flat number 6, something like that.
Right, right.
To have this structure, we need to have that what is the main street, what is the sub street, what is the block number, and what is the plot number. So unless and until we have this structure, we cannot come up with. But when it comes to a GPS number, what we have come up with that we are having the inherent property in form of a number,
Yes.
and rest all will be mapped against that particular number. So it does not matter that actually it does not matter whether I am having a plot there, or I am having a mall there, or I am having a school there, does not matter.
Right.
This variety of data, because when I am having this definition as my house or my plot or my residence, the structure is very, very different from when I am defining a school.
Yes, yes.
So the traditional database, every time I'm saying that I'm covering the schools, it would be a different data structure. I will have to create another table for when I'm defining, for example, shopping complex. When I'm defining a plot, it would be different. When I'm defining a flat, it would be different. But when it comes to GPS, it's all the same. There is
Right.
an inherent numerical latent function that we have built into representation of my data. So that is what makes it really, really powerful.
Yes, yes. And computer is very good for numbers. So
And
that
computer is extremely
Right.
good for numbers.
Yes,
It's the first language of computer.
yes.
After
Right, right. So excellent explanation, and I think we already set the background for audience to understand how important is this vector database, especially for dealing with unstructured multi-model data, right?
Yeah, and in data, like to add, in data it is always, for example, when we are talking about, let's say, an image.
Right, right.
When we are talking about a structure in the image, a bridge. Now, what would happen is that my system, my computer is supposed to extract a bridge out of it, and then that's the end of it. If I want to say that it is a suspension bridge, I have to add another parameter to it.
Right, right.
Now, when we are having very powerful compute systems, then there are other latent functions when I'm training a model, and if I'm showing it n number of bridges, then there has to be some mechanism, some latent function, which should be able to capture that a suspension bridge is very different from a cantilever bridge, for example.
Right.
So those differentiations, or this is a bridge on top of a river or a top of a water body versus it's a bridge on top of, let's say, a living settlement or a canyon. So these kind of differences, although not a part of my previous knowledge, not a part of my rule, there has to be some mechanism to capture it.
Yes.
Which I can label it later. So how do I capture it? I cannot do it when I am having a structured approach to it. It has to be fluid there.
Yes.
So that's actually the power of using a vector database, or power, or actually the need of it.
Yes. Because now, like if you look at the around the world, most of the data is unstructured in nature, and most of the data coming is unstructured from wherever you are collecting the data, and so that will, definitely give the need of vector database, some kind of technology which will deal with large set of unstructured data. You are right.
It is unstructured and it is unpredictable also.
Yes.
So today I am capturing the same data with X number of parameters. Tomorrow I will be setting it up with a different set of parameters.
Yes. The parameters and the set of parameters both are dynamic in nature, right?
Both are dynamic. Yeah.
Okay, that is really a great explanation. Let's move to another set of question now, and as you know that one thing is that a new technology come into the picture, then surrounding hype is also getting created. So, like it is like, what market drivers do you see here, which is fueling the growth of the vector database?
See, it is like vector database. It's not that vector database is something new. It has been around. Just like when we talk about machine learning. So there are tons of machine learning algorithms which were actually found before the first line of code around machine learning was written. So most of the algorithms are pre-1960s.
Right.
So things have been around, but the use or the need in real world has kind of boomerang because we are having huge compute capacity now.
Yes.
And as the compute capacity increases, as the usage goes lower, usage goes higher and higher, cost comes lower and lower, these things would increase.
Right.
So lot of things which are right now in form of a structured way, because we know this is what we want to capture. Tomorrow it would happen that we would probably not need it in that way. Tomorrow it would happen that since we can compute it, then why to put our brain in figuring out that okay, this has to be the structure and that kind of stuff. Today that is not the case.
Right.
It is in a big way.
Right.
So if those other ecosystems are growing, one of the key cog of this entire ecosystem, which is the vector database, which is a logical which is logically churning towards or gravitating towards vector database, that was also expected to increase.
Yes.
Whether it would be vector database as such or tomorrow some new technology comes in, that's beyond the point. But as we right now, it would be some vector database or some derivative of vector database. So tools might change. The logical technology will remain the same.
Right.
The logical need will remain the same. So something around vectorized storage systems. So this market, at least the one which is known, because there is in technology what happens is lot of market size is actually latent. If I am it in my computer, or if I'm using it in some POC inside my project, which I have not publicized,
Mm.
or if it is hidden behind the uh, behind a bigger technology or a bigger service. So those kind of things are always hidden. But what we know from industry surveys is that in 2023,
Yes.
this market was estimated to be around 1.66
Six.
billion dollars.
Yes. 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 1.7 billion around. Yes. Yes.
1.7, something in that tune.
Yes. Yes.
So
Correct.
just a database whose need is hardly a couple of years old
Mm.
in huge production systems.
Mm.
Uh, this growth is actually exponential.
Yes. 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 Correct.
Vector database might have been around for some time,
Mm.
but if we see the very recent trend,
Yes. Yes.
or very recent trend moving to in excess of 1.5 billion to $2 billion range,
Mm.
and that too, majority of it is outside these numbers. So
Mm.
when I'm using open sources and actually building something in my computer in my company as a part of a POC,
Mm.
or I'm removing something and plugging it in, which is
Mm.
not public to the world. So these kind of things are kind of hidden. So the real numbers could be much higher than this.
Yes. Yes.
And
Yes.
for
Correct.
I will consider that vector database might be around for quite some time, but as a technology to consider for surveys and for data research, I
Mm.
would consider this technology is hardly 3 or 4 years old.
Yes. Yes.
So
It is getting hyped recently. Very recently.
recently, right?
Right. Right.
So if it is a very small thing used somewhere in some high tech lab,
Mm.
nobody tries to figure out. We would not discuss it over a podcast, right?
Mm.
For
Correct. Correct. Correct.
recording,
Correct. Correct.
we discussing amongst ourselves
Mm.
as being techies, but we will not discuss it for a general audience for a podcast
Yeah.
kind of
In
environment.
fact, one point I have read it like around it is forecasted like a 24% annual growth it will
Yeah,
be until 2030.
and that actually could be an understatement.
Right, 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 right.
I mean,
Yes, yes.
although it is like 24%, but
Mm.
as I see it is something like this. What happens is that when there is a high, lot of people do not use vector database because they do not know how to use it.
Yeah, okay. Right, right, right.
So, so when the market increases, it is always uh, like compounding.
Yes, yes, yes.
So let's say that there are 100 people who know how to use vector database. Out of
Mm.
them, maybe 20 have the need, so 20 would be using it. But
Mm.
there could be 100,000 others who do not know about it.
Correct, correct.
So I don't know whether when this podcast becomes live,
Mm.
maybe we would end up some 10, 20, 50, 100, 200. I don't know how many of them actually
Mm.
jumping in to use vector database.
Yes, yes, you're right. And it is actually growing very fast and very
Very,
exponentially.
very,
So
very fast.
so putting any number is not actually I mean possible. Uh,
Yeah,
to
these numbers are kind of predictions where we say, okay, fine. In 2022, let's say there were 700 K market was sorry, $700 million was there in 2022. It became 1.1 billion. Now it is 1.7 billion. So we project it like that.
yes, yes,
Maybe
yes.
we add something that there will be some amount of compounding,
Hmm.
but in lot of technology, it is like a network effect.
Yes, yes,
So
yes.
so when it is like from let's say Facebook, we are having 1 million users, then from 1 million to let's say 100 million, and then it would explode because if you are not on So if everything else is using vector database, I will end up using. I cannot,
Right, right,
right?
right, right, right. All right.
So lot of use cases even now
Yes,
where actually it is a classic use case for vector database.
correct,
But
correct.
since we do not know about it, we end up because there are, for example, like taking from your previous example, like GPS and the road thing.
Right, right.
Even today, we use lot of our information around that, right? That we
Mm,
give our entire address and this and that.
mm,
But when you are ordering Domino's pizza, what happens? Even if you are storing all sorts of data, once you have filled in, once you have given the GPS coordinate, they
mm.
simply don't even look at your data
Right.
till they have used your, your GPS coordinate.
Mm,
Once they
correct.
reach your GPS coordinate, then they see, okay, fine, it is flat number 106 or 104. If
Right,
there
right.
is 104 around that,
Uh,
they will simply figure it there itself.
right.
So, uh, so I mean, this in a very similar way,
Mm,
just like the address with all the structured information is getting sort of uh, not irrelevant as such. That is important. That is, but for a majority of use cases, it is actually not required. It is redundant. It
right.
is kind of important, but it should be in the background kind of information.
Mm-hmm.
So those kind of things are kind of coming up and will be absorbed very very quickly.
Mm.
That's my opinion.
Yeah, yeah, yeah,
And
yeah.
uh, I think the other question, that second part of your question was around the key drivers around
Mm.
this.
Mm. Correct, correct.
So so for example, when we are talking about the real time analytics.
Right.
So since the data is kind of very varied,
Mm.
and data, let us say take an example of a vehicle.
Mm.
So right now, if I'm having a vehicle, the current car, it is not connected.
Mm.
The next generation car which comes in, it would be having lot of, like, the car even now is generating huge amount of data.
Correct.
The first step is that we, in lot of cases, we don't have sensors to capture the data.
Mm.
Then we
Correct.
are having some cars which are having the sensors to capture the data.
Mm.
Third level, where the cars are having data and some mechanism to actually push it to some analytic system. Now
Mm.
imagine this situation that I am having the same car. This car was capturing, for example, let's say temperature.
Correct.
So there is one car which is having sensor to capture the temperature of engine. Maybe
Mm.
it is doing now also. It is having some way to capture the temperature of the AC grill.
Mm.
The next generation captures the AC grill temperature also, as well as the temperature which is inside my cabin. The
Correct.
third generation captures the inside my cabin first seat and the cabin back seat.
Mm.
So this data is kind of proliferating, and
Mm.
if I want to really do some kind of analytics and some kind of coming up with some tangible workable information,
Mm.
what would be the logical place to store it? It cannot be the relational data. Otherwise,
Yes.
we'll be pulling it up from the relational data,
Mm.
again manipulating it in some way using some kind of code churning, and then coming up with
Mm.
and even this would kind of explode when it comes to autonomous vehicles.
Correct, correct.
Because if we are talking only about the present day cars, for example, a typical car, a modern day car, would be having somewhere close to maybe uh, 80 to 100 processing chips and sensors.
Correct.
Uh, a top end car at this moment of time has somewhere like 200 odd sensors, which covers something like 200,000 data points at every moment of time.
Mm.
Now, when it comes to auto, So, for example, when we are talking about the real-time analytics,
Right.
so since the data is kind of very varied,
Mm.
and data, let us say take an example of a vehicle.
Mm.
So right now, if I'm having a vehicle, the current car, it is not connected.
Mm.
The next generation car which comes in, it would be having lot of, like, the car even now is generating huge amount of data.
Correct.
The first autonomous vehicles,
Mm.
it becomes multifold, because where I am driving and taking decisions, to replace me as a driver to take a left turn or right turn, I would end up having an array of sensors to capture all the data, process it, and only then I can take the decision.
Yes, 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 correct.
Right. So even that most high tech car of which is driven by a human to a very basic autonomous car, the data captured will be multifold.
Yes, 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 yes.
So, and similar is a story around the IoT, the smart manufacturing.
Mm.
Uh, then we are talking about the smart homes concept. We are having the smart city initiatives where many things are connected, and then the data needs to be shared. Let's say that at this moment of time, I have some information using Google Map and all that. There is some road where traffic is there.
Mm.
Uh, uh, Maybe a smart city at some moment of time would be able to tell me that since I go for shopping every Wednesday,
Mm.
should I be told that if I, rather than going to this part of the city, if I go to that part of city, it would be better for me. So all of this actually needs huge amount of data,
Mm.
and
Correct.
the information hidden there is not structured.
Mm.
There is some latent information which needs to be pulled out somehow.
Correct, correct, correct.
So, and then there is another place which is very kind of very very important,
Mm.
uh, which is uh, 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 like even for vector database and this kind of information boom, cloud computing is very very important,
Exactly, exactly.
because when we are talking about this kind of data, since the volume of data is huge, the
Mm.
variety of data is huge, and the flow of data is unpredictable.
Yes, 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 yes. And in fact, I just wanted to add a small point here that yeah, this vector database gets a more real picture when cloud is getting matured now. Cloud is providing so much support to these kind of technology nowadays. Even AI ML, like Gen AI and all these things, are getting hype and getting the real worth because of cloud infrastructure right now, right?
Correct.
Mm.
Because let's say that if I'm having some kind of a uh, let's say that when we are talking about, for example, if I'm having a small house with some elementary, electric gadgets,
Mm.
then maybe I can work on my generator. I can
Correct.
have a quick unit, and I can start the generator whenever I need, and I can work on that. That is
Right.
possible. But
Right.
when I'm putting a lot of ACs and I'm having a computing facility and all that, then
Mm.
grid becomes very important,
Mm.
because my power requirement is unpredictable.
Yes, yes, yes.
So when it is unpredictable, I cannot have, let's say, if on peak I need 50 kilowatts of power,
Mm.
and when it is a lull period, I need only 1 kilowatt.
Yes, yes.
Then to satisfy me, I will have to put 50 kilowatts. It is
Correct.
not available in demand. I will have to have a huge capacity, which will be underutilized most of the times.
Mm.
Now, uh, this requirement, let's say regarding AI, ML, or Gen AI and the storage around that, that is
Hmm.
also have very similar kind of experience.
Correct, correct.
When I need, and then it is lull period.
Right, right, right.
So the only logical place where this all can be done very efficiently and at a without wasting the resources needed,
Right.
and that has to be cloud. So since cloud is maturing very fast, and so
Hmm.
uh, this is also kind of growing.
Yes, yes, yes. So I think audience has got lots of insight on real world application, I believe. So, no, but because we both are very techy also, so let's discuss now a little bit about the underlying technology, underlying tech
Mm.
things, which is useful to understand better of vector database. So can you explain a little bit about the vector embedding for our audience and then how these distance metrics are simplifying in the simple terms to understand vector database better way, like how it is useful in semantic search and other hybrid search kind of thing.
Okay.
Yeah.
Yeah. So I think that's a needed question.
Yeah.
So I think when we are talking about vector database, the language models, and the hype around this, I think it is a much needed question.
Right.
Uh, so I will try to explain it in two different examples as such. So the thing is that when we are talking about machine and human interface, the language of humans is different from language of machines.
Right. Right.
How we see things and how machine sees things, or how machine stores things, or how machine computes things is very very different.
Mm.
It is uh, just like that in terms of the real world versus the mathematics or numbers involved in it.
Yes. Yes. Right.
So now take an example of a triangle. Okay, so we say that there is a concept of similar triangles. So
Mm.
how a triangle is similar?
Mm.
When its angles are equal. So if angle triangle ABC and triangle DEF are same, when the angle A is same as angle value of angle A is same as angle D,
Right. Right.
B is E and C as F.
Mm.
Right? Now it is possible that angle A is actually this small, while angle the other triangle is this big, but
Mm.
they would be similar.
Mm.
Why? Because the angles are same.
Mm.
Now we can map the same analogy
Mm.
in terms of when we are doing a meaningful search. So let's say that I have come up with a conclusive remark which is only 10 sentences, which is an outcome of an entire book which is
Mm.
having 2000 pages,
Okay.
right?
Yes. Mm.
So long as the inherent meanings are coinciding, these
Mm.
are similar.
Correct. Correct.
So, triangle analogy,
Mm.
the angles are same,
Mm.
the overall meaning is same, but the sizes are way different.
Mm.
Now, the same thing happens when we are trying uh, to understand the language.
Mm.
So, let's say there is a sentence which is having a lot of words, a series of words.
Mm.
Those words are important in themselves.
Mm.
But what is more important when we are trying to find the meaning or trying to have a semantic search there
Mm.
is what is the underlying meaning in it. So
Mm.
we are looking for an angle.
Mm.
So what we do here is that when it comes to the uh, meaning, we take individual words, we try to assign a number, a kind of a correlation from a number to, so the entire sentence is mapped to a series of numbers, which is a vector. Now, what we try to do is that we try to measure the angle between the first sentence or a group of sentence and this new meaning depending on this matrix of vector.
Mm.
And what we are trying to measure is that whether the angles are similar.
Mm.
And so the one of the most popular algorithms that or the similarity algorithms that we use is cosine similarity, because
Yes.
cos of 0 is 1.
Yes. Yes.
So if the cos is same, it means both the angles would be
Same.
same. So difference between the cos value of the two lines, if it is 0, then
Mm.
it is similar. It would be
Yes.
100% similar,
Right.
right?
Right. Right.
uh, it's a same thing. Now, why this becomes important is
Mm.
where I would like to give another example, which is a very popular example in when you are giving machine learning uh, uh, explanation why where it fails. So let's say that all the data I have is only about cats and dogs. So I'm having n number of pictures of cats and n number of pictures of dogs,
Mm.
and I have shown all these pictures to a group of to this system,
Mm.
and I'm trying to get my output should be that when I show a picture to this system, it would return me whether it is a dog or a cat.
A cat.
Now,
Yes.
if by mistake, if I have shown all the dogs which are white and
Mm.
all the cats which are black,
Mm.
and then if to my system, if I'm showing a dog
Black cat.
which
Mm.
happens to be black,
Mm.
how they, it could be either way. We do not know,
Right. Right. We don't know exactly. Yes.
right? So that is where this is actually the veracity of data. Because if we are doing this kind of calculation,
Mm.
then there has to be some similarity that has to be either built in into the system.
Mm.
So when we are trying to make a difference, we, our brain is able to find out this difference, and then based on that we make the rules.
Right. Right.
Now the intervention of brain is not there. It is all machine. So
Mm.
when it comes to machine, we need to have this veracity of training data before it can be translated into
Mm.
the
Correct.
numbers.
Correct. 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 Correct.
So here the thing is that uh, when we are trying to find out the cosine similarity or
Mm.
any kind of similarity mechanism, we
Mm.
have to take the set of data
Mm.
which is into a different language. For example, let's say image is there. So
Mm.
from image, in the first approach, we will take that this image is dog, this image is cat.
Mm.
But that is not going to work
Correct.
because of this kind of problem.
Correct. Correct.
All I am saying is this image is there. Now all the stated meanings and all the unstated meanings, they
Mm.
need to be captured in form of a vector database. And
Correct.
once
Correct.
those similarities are set up, then I start marking them whether they are dogs or they are cats.
Mm. So in your example, actually, when you put the example, that is very much clear that vector database importance is major part
Yeah,
here, because that
correct.
database vector underlying technology works only on number, not the how we are
Only no.
perceived.
Yeah,
Yes, yes, yes. So
correct.
there it is very useful. So similar kind of example, even if you put in recommendation system, right? Like Netflix is using that recommendation, or
Right.
any other like image search kind of things, or product search on any e-commerce site. So many places similar
Right.
kind of application already applied, right?
Right.
So
Because
yeah.
finding out rules is actually very much dependent on people's expertise. So,
Hmm.
like they say that if you torture the data enough and
Hmm.
for long, you can extract any information out of it. Right.
Right.
But right, because it requires a lot of people's expertise.
Right. Right.
But when people's expertise is not there,
Hmm.
can I extract information just by giving it enough space or enough dimensions to the data,
Hmm.
and then basis that I can extract some kind of information? If I can do that, that is actually the real intelligence.
Yes. Yes. Yes.
Because if I'm providing the intelligence that okay, fine, on this do that, then that is always human dependent.
Yes. Yes. Yes.
When that is not the real intelligence. The real intelligence would only be when it is able to figure out on its own, provided I can provide enough dimensionality to even scope to say that okay, these things are different and how different they are.
Hmm.
So, in our example, we were having only two parameters. One was type of animal, and other was
And
color
color. Yes. Yes. Hmm.
and color. So two dimensions only.
Hmm. Hmm.
If I can give hundreds of dimensions, it would be able to pick the information that okay, fine, this thing which is like a tail, it is different. So whether we
Hmm.
call it tail or not tail is immaterial. But
Hmm.
capturing the information that there is some kind of a tail kind of thing, that protrusion is there,
Hmm.
so that has to be one dimension.
Right. Right.
So the larger my data embedding is, larger my vector embedding is, it is having more number of parameters. I would be able to differentiate between the two in a more intelligent manner.
Yes, yes, yes. As we get larger vector size, definitely we are very much sure about what you
Yes,
are predicting,
correct, correct.
right? So
Yeah.
one thing is like cosine similarity, another is Euclidean distance. So how these two are playing here? Can you explain a little bit for our audience?
Yeah. So like the cosine similarity is about measuring the angle.
Right, right.
Euclidean distance is about measuring the distance between, let's say that if there is one data set, how close that data set is from the another data set which I am providing.
Yes, kind of
So,
like example, like if somebody is looking for sunset, like how they can
yeah,
able to find or search any other image which is having similar kind of features like sunset
correct, correct.
available, so that can be determined by Euclidean distance by using the Euclidean. Right,
Yeah,
right,
that what is the nearness uh, from the other data set.
right, right, right,
So maybe if I have to search sunset uh, in a particular picture which is having other things with it. For example, if it is having let's say flowing water or a mountain.
right.
So when we are talking about a cosine similarity kind of thing, then it might be very different because it is having other aspects. So
Hmm.
there, so sum total of both would
Hmm.
come up with.
Right, right.
Uh,
And there are so many examples like nowadays especially LLM application is using, which is called hybrid search, like keyword search as well as your semantic search. These two is
correct.
actually enhancing the search capability, right? You are also perceiving
So
this as the same way, right?
yeah, yeah. Actually, that's very. So these are known as hybrid queries, right?
Right, right.
So in hybrid queries, what happens is that at times you would be having a keyword search. So
Hmm.
when we are doing a Google search works pretty well, right?
Right, right.
But the problem with Google search is that it does not give you a semantic meaning.
Yes, yes,
If
yes.
you know the exact search word, it will give you a very good result. No
Right,
doubt about it.
right, right.
Now, when it comes to hybrid queries, it is something like again to pick up from, let's say, Domino's Pizza.
Hmm.
So let's say you are ordering a pizza. Okay.
Hmm. Hmm. Correct, correct.
Now it is possible that when you are searching a pizza, and let's say if it is not Google giving infinite number of links, let's
Right.
say I have a feature where it has to give only one link. I don't want to load my servers.
Hmm.
Now, if I know exactly that I want a pizza,
Hmm.
then it will give me any pizza.
Hmm.
And then I say, oh no, no, actually I needed pepperoni on it. So
Hmm.
then I'll write pepperoni. I add pepperoni to it.
Hmm.
What I get is pepperoni. Then I say, Nini, last time I had eaten it was little hard. Maybe I throw a picture of it which I had taken. This kind of thing.
Hmm.
Now here, what is happening is that I know that I need a pizza. I know need pepperoni pizza. This much I can provide you,
Hmm.
but it looked something like this.
Hmm.
Now, something like this is actually transforming into something which is having a crispy crust, for example.
Hmm.
So, extracting this information, which is like crispy crust, merging it with pepperoni and pizza, and then pushing it, and especially when let's say that this pizza which is uploaded from this image doesn't actually belong to Domino's. It is
Right.
some other company's pizza. So
Hmm.
so this is actually a typical example of a hybrid query where
Hmm.
the semantic information is coming from some other source.
Hmm.
It is getting merged with your keyboard inputs,
Keyword. Yes, yes. Keyword inputs.
right?
Correct, correct. Right.
And then the entire thing is getting uh, you know
Search is
merged
as
together,
right, right, right.
and then that is used as an input to search.
Right, right. In fact, it is wow factor for recent things like that is how user is getting so much valuable search by even
Yeah,
mentioning.
because at times user does not know,
Hmm.
because like when it comes to pizza it is fine,
Correct.
but let's say that my queries could be as bizarre as this is my face, can you suggest something a nice pair of specs for me
Uh,
now, or maybe I can put some uh, maybe this is something which Facebook can do.
hmm.
Maybe that I can drop a request to Facebook where which says, see, I have been active on your system for like whatever period of time.
Hmm.
Uh, Suggest me something which looks good on me,
Hmm.
and based on likes and my previous attire and my graduation towards that. Earlier I was using very light colored clothes. Now I'm using little darker shades.
Hmm.
So what I will like.
Hmm.
This is very because earlier the approach was very different. It was like when you knew what you were searching and you had time to scroll through things, only then you were doing that.
Hmm.
But now, even when it comes to e-commerce, the uh, behavior of customer is slowly going towards the old days when you used to enter a shop and
Hmm.
you started telling in some vagueness to the shopkeeper, no, no, I don't want this, something with this, which should look something like that. And
Hmm.
this all is vagueness. And the
Hmm.
shopkeeper used to figure out. He
Hmm.
would talk to you if he is a good salesman. He would talk to you, and what he is available, he is having, he will figure out, and he
Hmm.
will provide some kind of a match, right?
Correct, correct, correct.
Now, same thing, same experience has to be provided by the e-commerce vendor.
Correct.
So the previous approach, keyword approach, is about that if I am looking for, let's say, polo t-shirts,
Hmm.
if I say polo, and if it is not there, the story ends there.
Correct.
But
And they will.
here,
Hmm.
yeah, but here the case is very different. Here it is,
Correct.
although you don't have polo, but see, you actually like, uh, round necks also might look good on you.
Hmm.
So how you will provide all that information? This
Hmm.
is where the things would go. So that's where it would be very useful,
Correct. Correct.
because
Correct.
only product codes and descriptive terms are not going to help.
Hmm.
It would be the input,
Hmm.
the how the input is kind of mapping with the uh, the available product codes.
Correct. Correct.
uh, because it does not matter if I keep on suggesting you that okay, it will, I have this kind of information, these kind of things are there, but I have
Hmm.
nothing that you are looking for,
Hmm.
is actually a bad business. So it
Correct.
has to
Correct.
be what we have and what best suits from
To your
my
concern.
content.
Right. Right.
So
Correct. Correct.
so yeah,
Yes. Yes.
so
Yes.
that is where it's going to have
Correct.
some application.
Right, right. Very good explanation, Rahul. So, for audience, I want to add a few things here that apart from this podcast information which we are getting through the podcast, we are also sharing you the technical articles where you will get the hands-on information. How you can I mean use vector db in your real world application. So those information you will get in an article, and we will share you all these links in video description. So as per your requirement, you will go through and go. If you have any concern, any doubt, any comment, please put it in a comment so that we can see and we can reply you. And now coming back to our podcast again, let's as
So
we
some of
all.
your articles have been very useful. So I have also seen them.
Yeah, yeah, yeah.
So
Right. Thank you.
yeah,
Thank
they
you.
are very well explained.
Yeah, yeah.
So
Yes, yes. And yes, and of course, I am getting all these information from expert like all of you and other friend circle also. So we are getting all these from our circle only. And so, okay, so until now, we have discussed all good things about the vector database. I
mhm.
think no technology is without any downside. So let's bring
Correct.
little bit about the downside of vector database also for our audience.
See, like they say that there is no right solution to anything.
Right.
It is it is only the least damaging uh, path that we select out, right? So when it comes to databases, vector databases, why we have uh, the relational database, for example,
Mm,
because it is simple.
mm.
The
Correct. Correct.
Although it requires little bit more space than needed, it is
Mm.
simple and it is
Very
based
intuitive.
on
Intuitive
knowledge.
also. Like you
Yeah,
already have a template kind of a specification kind of things. So
correct, correct.
yeah. Right. Right.
So it is based on my knowledge.
Mm,
I will put anything in data
mm.
as per my knowledge, as per my understanding. If I
Correct.
know my rules, this is how I segregate things. That is where I'm putting things.
Correct. Correct.
So the relational databases are actually simple and intuitive.
Mm,
But when it comes to vector databases, if I do a select star from vector databases, I would not be able to figure out anything because it would look like 0.91 comma minus
all
0.
numbers.
All numbers.
Right.
And at times it would be like 1536 or whatever is that number which we use for LLM thing.
Uh,
So every word or every chunk gets converted into 1500 numbers, and that is the set of things. So nobody can figure out what is there.
correct.
And while it is good that when it comes to vector databases,
Mm,
if I am having a sentence or variety of data, to process the variety of data, I would need lot of computer to make some sense out of the variety of data. I will need lot of computation,
mm,
but here the computation comes upfront. So
mm,
let's say that if I'm trying to understand a book,
mm,
now when I take the book and I convert it into a vector embedding, that
mm.
itself is a very compute intensive work.
Correct, correct, correct. You're right.
So So let's say that in a very uh, it's a data which was shared long time back, maybe more than a decade back. Somebody at Google said that uh, whatever has been written or whatever data has been generated before today,
Mm,
uh, Google generates the same amount of data every 2 days, I think.
mm,
So this is the volume of data which is coming in. Now, if we are having so much of data
mm.
and the entire data needs to be mapped into a vector embedding to make some sense out of it,
Correct.
it is uh, it is actually very compute intensive, very compute intensive,
Right, right.
and you need the uh, uh, the CPUs are obviously not going to serve the purpose. You need to have the GPUs
GPU.
or the
Correct.
TPUs which are pretty optimized for that.
Mm,
So that is one thing,
mm,
which is the computation cost, and
mm.
then obviously computation cost has a direct bearing on the environmental challenges, because there is a carbon footprint and which is
Correct,
huge.
correct, correct, correct.
Then there is another one which is around scalability,
Mm,
because if we are having huge amount of data, how you are going to scale.
mm.
Uh, and when it comes to scalability, an obvious downfall or an obvious extension to this problem would be latency.
Mm. Correct, correct.
So as the scale gets larger and larger, your latency is going to be. And there is one which is uh, kind of most important thing, which is the quality of the embeddings.
Correct, correct, correct.
So
You
there
are
is
right.
always a problem of uh, kind of data poisoning.
Mm,
So if my data itself is not rich enough, I'm
mm,
never going to come up with any kind of meaningful input.
mm,
So kind of this is not very specific to vector database as such, but
mm,
to this ecosystem it is important.
mm,
I mean, vector database per se is not responsible for bad quality embedding.
mm.
But if my ecosystem is feeding me bad quality embedding, it is like as say they
Right.
say dirty.
So can we say that vector data is not going to provide a great result
Yeah,
until unless your data is not right. If data is not right, then of course vector DB is not going to give you
obviously they
great
cannot
result.
do it,
Yeah.
and then this is coming at a cost.
Mm.
So even if it is a dirty data, still it is coming at a cost.
Cost, right. Mm. Correct, correct.
So which is multiple times that of and cost and complexity.
Mm.
Because when it comes to relational databases, it comes with very low complexity. You can
Mm.
see, you can figure out, you can see the data, and you can
Mm.
map it out that it's not right. But
Mm.
here we it's relatively much more complex.
Correct. Because here most of the thing is a number. So
It is, yeah,
you are getting the search result, what kind of like
correct,
embeddings they have searched, what similarity they have seen. So it depends
right,
on many different aspects, right?
yeah.
You are right.
So it cannot be a panacea or a silver bullet for everything. So
Mm,
obviously, with any technology hype, what happens is that uh, the moment technology starts getting traction, people start thinking that you can transform everything around this.
mm, mm.
So that is not the case. Obviously, like since there is a
Right,
hype,
right.
people are stars and moons,
Mm,
but it definitely has incredible capabilities. But it is not solution to everything. It cannot replace. Uh,
right, right. In fact, I would say that you have put a very balanced view of vector database. Like it is not a silver bullet for everything. Like you have to
yeah,
use very uh, knowingly, like are they actually solving your problem or not? If it is solving, then you should go for
correct.
it. And if it is giving you enough business aspect, then also like think about the cost also, like if it is going
Hmm.
to give you viable solution to your business, then only you can proceed. Otherwise, like relational database base have their own charm. It is not like it is going to out from the market. I mean,
Right,
it should persist. And so every new technology also have their own downside and their
right,
challenges. But if
right.
you use judicially, if you use knowingly, like what exactly for what purpose you are
Correct.
using, it is definitely going to
Correct. It is like the similar example that if I'm having a hammer, everything looks like a nail. But uh,
you
right.
should
But
you
then
should
if I come up with let's say a drill or a screwdriver, that
Hmm.
does not mean that I would replace nail everywhere and start plugging it using a screw everywhere. So
Hmm.
nails also have their importance. They are simpler, they are quicker,
Hmm.
and whatever. I mean,
Hmm.
so that's the idea.
Hmm.
Or for example, like let's say cars are very useful, but then so are bikes
Hmm.
because they are two wheel. They can go and they consume much less fuel. So
Hmm.
it is very similar kind of analogy.
Hmm.
So
Correct, correct.
although very potent, they have their own place.
Hmm.
And
So we are now almost in the last segment of our discussion. If you can
yeah.
put little bit about the future trend of industry, how you are perceiving right now, like where it is going.
See, just like I said, that everything has its own place, like relational databases. So, specifically from a database perspective, I think it would be more like a part of a hybrid architecture where
Hmm.
you have traditional relational databases, you are having the NoSQLs, other data stores, some part of it, some what makes sense needs to go with the vector databases, and this unified uh, uh, data source is going to act as a data mart to the downstream systems.
Yes, yes.
So the current structure of data mart, where you are having varied source of information, this thing also has its own place. And for the right kind of data sets or right kind of applications, we can have our data moved into a vector database store.
Hmm.
And then, like the compute requirements, as we were discussing, that since it is very compute intensive, so the newer technologies which are kind of in their infancy or pre-infancy stages,
Hmm.
like quantum computing.
Hmm. Correct, correct.
Now, when we come to quantum computing, uh, the amount of uh, uh, amount and the speed of processing is going to go multiple fold. At least that is what quantum computing promises to come forth with.
Right.
So what we can achieve through GPU,
Hmm.
we can achieve multifold of that using.
Quantum.
So once that comes in, it is the importance of vector database is going to go much more than that.
Almost in the last stage now. Let's discuss little bit about the how you can see that if a business leader want to adopt a vector database in their business, what you want to suggest for them.
Yeah. So as we were discussing that vector database is not a silver bullet or a panacea for everything.
Hmm.
So he has to find out the suitability or the particular use case where you need to have this database in place.
Correct, correct,
You cannot have a vector database put everywhere.
correct, correct.
That way, wherever you find anything, you just put in your database. So there are very very specific use cases where database where intuitively it looks like that vector databases would be a better option.
Hmm.
The specific cases would be wherever you are having a variety of data
Hmm.
and the very structure of the data keeps on changing. So
Hmm.
those kind of use cases where there are latent meanings to the data
Hmm.
which are beyond the physical attributes of the data itself.
Hmm.
So those kind of use cases are where it makes good sense. For example, let us say that when we are talking about the viewership pattern,
Hmm.
so it is not that just because you are also a tech person and I am also from a tech background, we are going to have similar interest in movies, for example.
Correct,
It
correct.
might be, there could be weightage, but
Hmm.
so on one aspect, our cosine similarity is like very, very aligned. But
Hmm.
there could be there are a multitude of other factors which would tend you having a different kind of viewing pattern,
Correct, correct, correct.
right?
Hmm.
So when it comes to, for example, personalization,
Hmm.
the recommendation system, so these kind of data could be the very, very the uh, uh, what just what first comes to the mind when we are talking about the vector database use cases.
Hmm.
Now, since you are pre-processing and converting all of this data,
Hmm.
which is adding the viewership pattern into vector databases,
Hmm.
so because of this pre-process, and since it is already converted into some kind of number where you can do a simple matrix multiplication or
Hmm.
finding out a cosine similarity, and you can find an exact recommendation, you don't have to dig into a vast ocean of data to figure out what I will like and what I will not like.
Hmm.
Neither you have to figure out a static predefined rule to my choices.
Hmm.
So that is where the recommendation is going to be more efficient.
Hmm.
Now imagine a situation where my recommendation is, let's say, even if I do a 10% improvement in accuracy of recommendation
Hmm.
and 20 or 30% faster recommendation, if I'm able to churn out,
Hmm.
it's going to be a game changer.
Hmm. So basically, you are suggesting to them that it is not one silver bullet. Like you should not use this vector DB or any such kind of similarity search in, I
Mm.
mean, altogether, different zone. It is like you can use
Correct.
it as a hybrid parameter also. Like meaning it,
Right.
like whatever the metadata based search currently you are using, on the top
Yeah.
of it, if you can use this vector DB concept and
Correct.
improve your accuracy or competency, fast reach to your customer, and
Right.
if by that way, if you can reach your 10%, 20% more customer, that would be fair enough to
That
justify
is fair
that.
enough. So,
Right.
so rather than, because it is not some kind of a technical upgrade or some
Correct.
kind of a technical that earlier we were using it wrong and now we will be using all right.
Hmm.
So that is not the idea. The idea is to find out the use cases,
Hmm.
and if it aligns with the vector DB concept, that we can figure out that over and above the existing solutions, pulling data from the same source or replacing some of those data sources to a vector kind of paradigm, if we can improve something.
Hmm.
So it is like a complementary technology and not a replacement per se. So
Correct,
that
correct.
is my view.
Right,
It's
right,
more like a strategic business tool and not some kind of a fancy tech which has come in, which it's not like a paint job.
right, 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 right,
It's not a paint job. That earlier it was yellow. Now I need to paint it red.
right, right. Correct, correct, correct.
It's a kind of a useful addition to your arsenal.
Right, right, right. So you should not see it as a silver bullet, as you mentioned rightly. It
Yeah,
is like a addition of things you should do in your business, right?
right. And more the world is going to be data driven.
Exactly.
It will be uh, it's kind of there is no other option. We'll have to
Mm,
go through at least
mm,
a fraction of it
mm.
needs to move to a very vectorized
Mm. And you
data
also
storing.
see, that in the future also, like as vector DB also getting matured time to time,
Correct.
and there are more use cases arise,
Right.
which business leader has to look around, and they can contact us also. Like as an expert, we are always available to solve their problem, so they can
Right.
always. So I think this is a nice breakdown of a complex topic by you, Rahul, and I think this is very helpful for our audience to understand vector DB. Very fundamental way. Of course, we are not solve everything here in this 30 to 35 minutes podcast. And of course, we have lots of technical breadth, but we have not gone here due to our audience. We believe that our audience is very, many audience who are not that much tech savvy also. And so kind of like hybrid setup audience. So that's
So
why
we can
we have,
have a podcast where if there is a demand from the audience,
right, right.
depending on the audience need, we can have another podcast where we
Exactly.
can dig deeper or
Right,
uh,
right, right. That is what we have planned also. And also, by not only that, if they have any direct interaction, they want their own problem to discuss with us, then we are
yeah,
always available to solve their problem, right? For that, they have to contact us. We can share
yeah,
our
absolutely.
contact. Yeah, yeah. So that is what we can do here through this podcast. So at the end,
Right.
thank you, Rahul, for giving your insight. And I think we are very much blessed here to get your insight on this topic. And
So
I believe that this podcast will solve many fundamental understanding of vector database to many our audience. And thank you.
yeah, glad that I was of help. So thank you.
Thanks a lot.